Hari, okay. Then let's start. Hari, if you have any issues, any audio, video issues, just let me know. We'll fix it slowly. Hari. Right. අවුලක් නැහැ දැන් පේනවනේ. මට පේන්නේ නැහැ මම පේනවාද කියලාවත්. Shape not bad. Right, then we'll start. Hari. So today we'll be starting the second phase of equilibrium, right? The second stage of equilibrium, which is under that the next three parts, which will be the Raoult's law, and then the phase equilibrium, and then pH, right? So the most difficult part out of those three will be the pH section. So I'll keep that as the final part. Normally in your resource book, pH is done as the second part, I guess, but I'll do it as the sixth part because that's the most difficult. Then to do that, you need to have some sort of idea on how to handle an equilibrium. Again, it has nothing to do with the previous equilibriums, but then you have a idea on how to do questions. Then you can go for the most difficult part, right? So that's what I'm trying to do. And today we will be starting the fourth part, which is the equilibrium part, which is the Raoult's law part, right? So that's a name which I use. That's not the proper name that's not the proper name for what we normally use. Right? Okay, so we'll start. The name which we use for Raoult's law is that ආය පොඩ්ඩක් සද්ද වැඩි කරන්න බැරිද? සද්ද අඩුයිද? මං හිතන්නේ බෑ. ඔයාගේ පැත්තෙන් තමයි මම හිතන්නේ වැඩි කරන්න වෙන්නේ. From my side, I think this is the max. Not the max, I don't have control over the mic. ඒකයි තියෙන්නේ. mic එකෙන් දෙන input එක, that's the input. අන්න එහෙම පොඩි case එකක් තියෙනවා. Is the input low? අවුලක් නැහැ නේ. If it is not manageable, just again manageable again. If it is low, පොඩ්ඩක් කියන්න මේ. Do you want me to check it? Or is it okay? Earphones දෙයක් ගහලා මේ I did not check the output. Okay ne? Right, okay, then I'll keep it as it is, right? If you have issues, let me know, right? If the audio is low, just let me know because it might even affect the recording. Okay. Right, we'll see whether I can hear. Sound is okay. Right. Okay, if it is okay, then we'll just continue. අවුලක් නැහැ, we'll just continue for the moment. මේ මට තියෙනවා පොඩි අවුලක්. මේ I'm a really sensitive person to current. හරිද? Even if I just touch a conductor, I'll get the shock. ඒකින්ද මට මේවා handle කරන්න බෑ. Right? Normally I don't adjust the camera. My brother does it, but he's not here. Hina mara poddak me අල්ලන්න බෑ මේ even when I touch a mic I get that shock. I done I'm really sensitive. මගේ ඇඟේ තියෙන මේ the iron composition might be high. I don't know. Iron means not Fe. The iron ION iron. Right? Then it can happen. Anyway, now regarding Raoult's law part, so the name Raoult's law is given for a law which we are going to use for a certain type of a equilibrium. Now before using the Raoult's law, we need to know what type of an equilibrium are we going to discuss today. That's what we are going to do today. Again, now the first type was general equilibrium. Then we discussed about KSP, which was for an equilibrium which was a strong electrolyte and was sparingly soluble in water. We use KSP for those sort of equilibriums. and then we use the KD term for a system which had a equilibrium regarding two mixtures, two liquids which were immiscible. So those were the three equilibriums, those were the three systems which we learned about. Now today we are going to learn about a different system. So we'll write down the topic, then you will understand the type of the system. So this is the fourth part of equilibrium. We covered three. This is the fourth one. Write down the topic. Liquid vapor equilibrium. Liquid vapor equilibrium. Liquid vapor equilibrium in binary liquid systems. In binary liquid systems. Liquid vapor equilibrium in binary liquid systems. Right? Liquid vapor equilibrium in binary liquid systems. Right? Liquid vapor equilibrium in binary liquid systems. Is it clear? Right. Now, this is a new part. Hari. Mekai kaling e relationship pack na. So if you have doubts regarding the previous parts, you can still get this done properly and make sure that you cover the previous parts. Go through the recordings. Hari. Now here, when you read the topic, you can understand. If we compare this with the third part of equilibrium, the KD part was again for a system which had two liquids, right? It had two liquids, but those were immiscible. Those were immiscible liquids. And to those liquids, we added another substance. Now for the KD part, we had two immiscible liquids and we added another substance which was soluble in both these two liquids. Now here for the fourth part, we are not adding anything. We are talking again about a system which has two liquids. That's the meaning of binary, right? Binary liquid solution means a solution which contains two liquids, right? The difference is that those two liquids can mix. On the fourth part, we are considering a solution which contains two liquids, let's say A and B, which do actually mix, which means they form interactions together. We'll learn how to identify whether two liquids mix or not later, but just for the normal understanding, these two liquids will mix. And then what happens is, after, let's name this as A liquid and this as B liquid, this is the solution, right? Here those two won't mix. If this is A liquid, this is B liquid, these won't mix. This is what we learned under the third part, under KD. Now here these two will mix, and we are considering the equilibrium not between these two. We are not interested about any equilibrium between these two. There is no equilibrium in these two. But this A liquid will form a gas, which is known as the vapor phase, right? Vapor, vashpa kiyala kiyanne the vapor phase, right? And this will also vaporize a little bit and it will form a gas. This is not only about the vapor which we will get after reaching the boiling point, right? You know there's a difference between vaporization and evaporization, right? Evaporization is forming vapor without reaching the boiling point. Now when you dry your clothes, you use evaporization. The water in your clothes will evaporate due to the heat of the sun, but those water won't reach the boiling point, right? That's known as evaporization. So that also happens here, and even it can reach the boiling point and then it can vaporize. Both can be happening, but somehow this liquid will vaporize forming a gas, this liquid will vaporize forming a gas, and then there will be an equilibrium between this. There will be an equilibrium between A liquid and A gas. We know that, right? Generally, if we have a liquid and a gas in a system, there will be an equilibrium, and between these two also there will be an equilibrium. Due to these two equilibriums, there will be a relationship between this and this, and also there will be a relationship between this and this, which we will derive, right? This is one of the most easiest parts in equilibrium. The concept might be a little bit difficult to understand, but the equations and what they expect from us in our A levels are really easy. Eka mara lazy podi equations deka tunak tiyena, and then you can easily figure out the question. Normally all the questions are in the same type. So that's what it is. Then Again, read the topic and check whether you can understand, whether you can see this concept inside the topic. Right? It says the liquid vapor equilibrium in a binary. Binary means two liquid solution. Right? That's understandable. Ne? තේරෙනවනේ අවුලක් නෑනේ. හරි. Now then we can continue. Okay. So if you want, you can just draw a small sketch and explain. You can write it for yourself that we are going to talk about a system like this and these are the equilibriums. Right? If you want to understand. Hari, I'll give you 30 seconds. If you want to write anything, දාගන්න පුළුවන්. Hari. Right? Okay. Then ප්‍රශ්න දිනන දාන්න. Then this system will be divided into two types. This now we are trying to learn about binary liquid solutions. Those binary liquid solutions can be divided into two types. The first type is ideal solutions. Ideal solutions. The second type is non-ideal solutions. Right? Non-ideal solutions. Is it clear? These are the two types. Now first we will be analyzing about how ideal solutions act and what type of equilibriums can we reach under the ideal solution, and then what sort of equations can be derived, and 95% of the theory and questions will be asked regarding ideal solutions, something like gas laws. Now for gas laws also 95% of the questions will be asked regarding ideal gases. They will have very small amount of questions and theory regarding real gases because those are actually difficult. At your university, if you are interested, you can learn those. Same here, these things will be discussed more in your at your university level. Hari. So the first topic under this will be, after the topic, if you want you can write anything. After that, the first topic is ideal solutions, right? Or else you can write ideal binary solutions, right? Ideal solutions. No, what's the topic? The topic is the main topic. If you joined late, the main topic was liquid vapor equilibrium in binary liquid systems. Liquid vapor equilibrium in binary liquid systems. Right? Liquid vapor equilibrium in binary liquid systems was the main topic, the fourth part of equilibrium. Then the subtopic under that, Roman number 1, put Roman number 1 and then write ideal solutions. Right? So for liquid solutions, we can divide it into two separate parts. One is ideal solutions, right? We are going to analyze that part for 95% of the content of this part, and then we will get a small idea on how non-ideal solutions will act, right? Okay. So it's ideal solutions, right? It's ideal solutions. Again here, ideal solutions do not this is a hypothetical concept, right? Same for gas, same like gas laws. Ideal solutions doesn't exist. The idea of ideal solution is that two liquids which have very near physical properties, right? If you take two liquids which have very similar physical properties, then though the mixture of those two can be known as an ideal solution. For an example, let's take benzene and toluene. Now you might not know these compounds for the moment, but doesn't matter. If you take benzene and toluene, right? Benzene is C6H6, something like this if you know organic. Toluene is so toluene is this. Benzene and a CH3 on top of it is known as toluene. So if you compare these two, if you know a little bit of organic, you can understand that the molar masses are nearly similar, right? Here the molar mass is 78. Here it's 78 plus this, which is 93. Not a big difference compared to the actual molar masses, right? 78ක් එක්ක බලද්දී another 15 is not a lot නේ. So the molar masses are nearly similar. And then you know that we have 3 double bonds. Here also you have 3 double bonds, and the structure of benzene is similar for both. Only the CH3 part is different, right? So if you have a slight knowledge on organic, you get the idea that both of these have almost similar intermolecular structures. Maybe structures are almost similar except for this part. Therefore, the physical properties such as the boiling points, the melting points, everything are nearly equal. Therefore, if we mix these two, if we get the liquids, so these two are liquids in a normal temperature, if we mix these two, then these can be known as an ideal solution. Another example, let's take hexane and heptane. These are examples which are given in your resource book, right? Hexane and heptane. Hexane is a hydrocarbon which has, rather an alkane, which has 6 carbons. The formula is C6H14, and then heptane is C7H16. These are hydrocarbons. So again you can see both are hydrocarbons, both only have carbons and hydrogens. So the only intermolecular forces are van der Waals forces, because these are very weak carbon hydrogen bonds, no hydrogen bonds, nothing. And also the molar masses are nearly similar. ඔක්කොම එක වගේ. The intermolecular force nature, the structure, the molar masses, everything are nearly similar. Therefore, if you take the boiling points, the melting points, all the other physical properties, let's say water solubility, everything is nearly equal. Then if you mix these two liquids, it's known as an ideal solution. So that's the idea, right? So put a star mark and write. Put a star mark and write. Mixture of two substances. Mixture of two or else compounds. Doesn't matter. Mixture of two substances which have similar physical properties. Which have similar physical properties. Or very close physical properties. Mixture of two substances which have very close physical properties is known as a ideal solution. Is known as a ideal solution. Right? Under that you can and also write down that this is just a hypothetical concept, right? We don't have ideal solutions because it's not possible to have two compounds which have exactly equal physical properties, right? So we can't have that, but we can have nearly ideal solutions, right? We can't have ideal solutions. You can write it down as a side note. If they try to trick you using an MCQ, the same concept which we apply for gas laws can be applied here. We don't have ideal gases, but we have gases which are close to be ideal or which can approach the ideal behavior, but not ideal gases. The same concept applies here. You can write that later if you want. Under that you can write examples: benzene, toluene. This is benzene, this is toluene. Then hexane, heptane. Also ethanol and methanol are given as examples under your resource book. Ethanol and methanol. Methanol is CH3OH. Ethanol is C2H5OH. Again, you can see both the alcohols, both have hydrogen bonds, and the molar masses are nearly equal. Can you repeat the last part? So, which I said, what did you say? Solution which contains, or a mixture which contains two substances which have similar which have similar physical properties is known as an ideal solution. Which have similar physical properties is known as an ideal solution. Hari. Then under that you can write down these examples. If you want, you can write the formulas as well. Right? Maybe ඉගෙන ගන්නවා under organic, you will learn these under physical properties. There's a separate section in organic for physical properties. Right? Right? Then put another small star mark and write. We'll quickly finish the theory. Just a small star mark and write. Important properties of an ideal solution. Important properties of an ideal solution. Important properties of an ideal solution. Right? Okay, there's a question. Are all those similar to each other, or is it like benzene is? Yeah. So I gave you 3 examples. These are 3 examples. We are always talking about binary solutions, which means a solution with 2 compounds. So these 2 are similar to each other. Therefore, mixing these 2 will give you one ideal solution. These 2 are similar. Therefore, these 2 will give one. These 2 will give another one. So I gave you 3 separate sets of examples. Harini? Benzene, toluene, heptane, hexane, and ethanol, methanol. Right? Clear? Ne? Okay. Then under properties. Hari properties වල තියෙන මෙහෙම කතාවක්. They have defined a very similar, very simple rule actually. If we take let's say two substances, A liquid, B liquid, have nearly equal physical properties, then if you mix these 2, you will get a solution which is A liquid, B liquid, right? Then inside this solution you have 3 types of intermolecular forces. One is the intermolecular forces, or rather intramolecular forces between A, right? No, you can't say intra actually, no, it's again inter. So intermolecular forces between the molecules in A, right? Now if A liquid means there's a liquid which contains lot of A molecules, right? මෙහෙම A molecules ටික තියෙනවා, and these are, let's say, B molecules. Between these molecules there are attractions, right? Between these molecules there are attractions. So those attractions can be denoted as FAA. F is for force. Now if you have intermolecular attraction or intermolecular force, that can be written as F. This is the attraction between molecules of A, right? මේගේ බෝල ටික තියෙනවානේ, මෙන්න මේ අතර තියෙන attractions. And again you have B. For those also you can write the intermolecular forces or attractions, which can be written as F, let's say FBB, right? And also if 2 liquids mix, now in KD those 2 liquids didn't mix, therefore we don't see this now, this type of attraction which I am going to teach you. But if 2 liquids mix like here, then there will be definitely attraction between A and B. A molecules will attract with B molecules, that's why they mix. liquids දෙකක් mix වෙනවා කියන්නේ definitely they need to have attraction between A and B. Therefore that can be written as FAB. So FA is the attraction between molecules of A, FBB is that between molecules of B, and FAB means the attraction between A molecules and B molecules. So the basic requirement to form a ideal solution, or the most basic property of an ideal solution, is that these three should be equal. So the first requirement is that FAA should be equal to FBB, and that should be equal to FAB, right? So this is the first requirement. Is that clear? So very, very simple requirement. So under the property, write 1 and write down this, and then you can explain it by yourself. I won't give a note. Write down this and explain what does this mean. If you mix two, I'll repeat it again. Pay close attention. If you mix two liquids, the attraction between A molecules is FAA, attraction between B molecules is FBB, then the attraction between two liquids are known as FAB, then those three should be equal, right? You can draw a small sketch, then write this down. That's the first requirement. Right? Podi theory meva. These are just MCQ points, not necessary for calculations. Right? Right, so that's the first requirement. Under that you can explain what is FAA, what is FBB, and what is FAB. I'll give you 30 seconds more. Okay, then because of that we'll get the next property, which is the enthalpy of mixing, or else mixing enthalpy of mixing, or mixing enthalpy is 0. Just write it down, I'll explain. Enthalpy of mixing is 0. Delta H is 0 here. Delta H is 0. That's the second property. We only have two properties. Right. Now, what is enthalpy of mixing? Do you have any ideas? What the enthalpy of mixing can? Have you heard that when you mix two liquids, or not even liquids, if you mix two substances, let's say you add few grams of urea to water, then what will happen? If you add few grams of urea to water, what will happen? Does anyone know? If you mix one acid with a base, what will happen? Answer those two questions. First one, adding urea to water, right? Yeah, water becomes cold. The temperature will decrease, right? If you add urea to water, then the temperature will drop. If you mix a acid with a base, then what will happen? Then what will happen to the temperature? Yeah, normally, generally the temperature will increase. Why? What are the reasons? This will be learned in the 5th unit as well. This is just a common observation, right? Why do we observe these two observations? What is the reason? මොකද්ද මේකට තියෙන හේතුව? Any answers? What are the reasons? What are the reasons? Yeah, either by mixing two substances, heat can be released or heat can be absorbed. Why? Now we'll try to break it down. Why can that happen? Now it's commonly known that when you add urea to water, heat will be absorbed. Heat will be, now you might not know what this delta H is. If you haven't done energetics, then you can join on next Monday or Saturday. I'll inform you the procedure on the group tomorrow, right? So here heat will be absorbed. Therefore, you will see that the temperature will be decreased. The heat will be absorbed by the molecules. Then once you touch the glass or the container, you will feel that the temperature has dropped. Here the heat will be released. Heat will be released. Then you can feel that the temperature has increased. Is that clear? That's clear, right? Okay, now here, why does that happen? How does it decide whether to release heat or absorb heat? For what do we need that heat? Now here, see, the heat has been absorbed for some reason, right? There might be a heat deficit, therefore it absorbs heat from the environment. There might be some excessive heat, therefore it might be released. How does that happen? For what do we need heat? Heat මේකට සම්බන්ධ වෙන්නේ මොකටද? Any answers? Exactly. Now this is a chemical reaction, right? If you are mixing two liquids, then as I said, you have interactions between a single liquid, interaction between a single liquid, and then the interaction between the mixture. Then what happens when you mix two liquids is the interactions between these, some, not all, some interactions between these two liquids will dissociate or break and then form interactions between these two. තේරෙනවද? මේ A ගේ interactions and B ගේ interactions will dissociate, forming interactions between A, B. For that, either heat will be released or heat will be absorbed. If you want to break a bond, if you want to dissociate a bond, then heat will be absorbed. අපි heat එක දෙන්න ඕනේ because it's difficult to dissociate a bond, right? So if you want to dissociate this bond, then a certain amount of heat will be absorbed. If you want to form this bond, when a bond is being formed, then heat will be released. Is that clear? That's the idea. So the resultant of all of those absorptions and heat releases will determine whether the final result is temperature decreasing or temperature increasing. ඒක තමයි idea. Is that clear? Now if you have, let's say you have A here, you have interactions between AA and then you have interactions between VB. Now once you mix all of those, what will happen is that, let's say this interaction is dissociated. මෙයාව dissociate කරනවා. And this is being dissociated. For that, energy will be absorbed. And then you have a single A, single A, single B and a single B, right? Then this A, this A will form a bond with this B. In that process, a certain energy will be released. So you need to, and here also this A will form a bond with this B. AB එකක් හදනවා. A certain amount of energy will be released. තේරෙනව නේද කතාව? That's the idea. So you need to get the resultant. How much of energy was absorbed? How much of energy was released? That will depend on the strength of the intermolecular forces. Then accordingly you can get the resultant. That's how the mixing enthalpy works. Mixing enthalpy වැඩ කරන්නේ එහෙම. Is that clear? Is it clear? අවුලක් නෑ නේද? I hope that's clear. Right. Now what happens is, in this question we learned that all the interactions are equal in strength. FAA is equal to FBB is equal to FAB. Therefore, if we consider a simple example, if we consider this example, let's say when you are mixing A and B, one molecule, one interaction between A, we'll only consider one or else we'll consider two. No, it's easy to consider one. We'll just consider one molecule of A and one molecule of B. We have a lot of molecules, but for the moment we just consider this. Everything can, so for the entire sample, this theory can be applied, this concept can be applied, right? Now, let's say, now try to answer my questions. I want answers. To dissociate this bond, 5 joules, no need to consider about the unit. Let's say 5, something of 5 was absorbed, right? Something of 5 was absorbed. Is it clear? Monavang hari pahak absorbed, right? Let's say it's joules. Then tell me, to dissociate this, how much of energy should be absorbed? How much? It's 5, right? It's again 5. Why? Because the same strength, the same strength for the intermolecular force. Therefore, 5 will be absorbed. The total absorption is 10. Right? The total absorption is 10. Then what will happen? Then, after the dissociation, we have a single A. What's wrong with this? Right. And then we have a single B and a single B, right? These two A's and these two B's. Then what will happen? This A and this B will connect together and form a bond. This is the dissociation part, this is the formation part. Now tell me, when these two form a bond, how much of energy will be released or absorbed? I want the number and I want to know whether it's a release or a absorption. Taggal again. When this bond forms, exactly, it will be 5 because the strengths are similar, but since this is a formation of bond, it will be releasing, right? Therefore, when these two form a bond, 5 will be released, which is minus 5. Releasing is minus, absorbing is positive, right? Then when these two form a bond, it will be another minus 5. Therefore, you can easily see it's minus 10. Then when you get the resultant, it will be 0. Now, these things are not necessary to be taught. In your resource book, they have just said to just teach the student that the mixing enthalpy is 0. No logic, nothing, you don't know how, it's just 0. But I teach you the logic, make a venahati kiyala dena, then you will understand better, right? So that's the concept. You can write this and under that put a star mark and write. Because the intermolecular forces are equal, or else you can write simply because of this here. You can write because FAA equals to FBB equals to FAB. Because FAA equals to FBB equals to FAB. Right? Because FAA equals to FBB equals to FAB, the energy required to dissociate a bond, or else the absorbed energy to dissociate a bond. Absorbed energy to dissociate a bond will be equal to, because FAA equals to FBB equals to FAB, the absorbed energy to dissociate a bond will be equal to the released energy when a bond is formed. So you can write it in your own words. The energy which is required to dissociate a bond will be equal to, the energy absorbed to dissociate a bond will be equal to the energy released when a bond is formed. So that's the idea you can write. Neither? Is that clear? If that's clear, if you want me to repeat, put it on the chat. If that's clear, if you can write it by your own, put example and just write down. This is just a small mathematical way which we can show that, right? But you will understand this, what we have written, right? So you can show, we will consider one molecule of A and one molecule of B. Let's assume that to dissociate this we wanted 5. You can write it. I won't guide you, you can just write it. I'll just guide you, right? So to dissociate this, let's say 5 was required. Then because of FA is equal to FBB, then to dissociate this, it's again 5. Then when forming this, it's minus 5. Forming this, it's minus 5. Therefore, the resultant will be 0. I hope you can write it by your own, right? If you want any guidance, let me know. Now this understanding is very important because later onwards we will try to understand what happens if it is this. Then by just studying that the mixing enthalpy is 0, it will be difficult. Then you will have to study the mixing enthalpy for this also. But if you know the concept, if you can write this down clearly, then you can understand what happens here. We will think about that later. හරි ඒකයි logic එක කියලා දෙන්නේ. Right. ලියමු බලන්න. Right. FAA, does it mean by the strength of... Yeah, FAA is the strength of intermolecular forces between A molecules. This is the strength of intermolecular forces between B molecules, FBB. FAB is the strength of intermolecular forces between FAB. Right, ලියමු බලන්න ටක් ගාලා. ලියන්න. හරි හරි alright අවුලක් නෑ නේද you can write it නේද පුළුවන් නේද on your own මේ කතාව මේ 5 කැඩෙන එක then -5 releasing 5 absorbing 5 releasing 5 each then it's 10 releasing here 10 absorbing here therefore the final enthalpy is 0 so this both will of these will happen simultaneously right තේරෙනවනේ now මුලින් 10ක් release වෙලා ඊට පස්සේ එහෙම නෙමෙයි the heat temperature will increase and then the temperature will decrease නෙවෙයි මේ දෙක එකට වෙන්නේ both will happen simultaneously but I just broke it down to two separate sections then you will understand that's why hari right so that's the general idea on an ideal solution quickly read it down මේ ටක් ගාලා මේ කියවගෙන යන්න මේ ටික up to what we have up to this point මෙතන what is an ideal solution the examples the properties of an ideal solution ටක් ගාලා කියවන් එන්න now we are going to move towards a more mathematical relationship or an equation we are going to derive an equation after this therefore quickly read this ගන්න කරපු ටික if you have doubts you can ask දැනට තියෙන ඒවා Hari? Is it clear? Alright, then if it is clear, the next main topic is Raoult's law. Raoult's law. මෙහෙම ලියන්නේ එක. Raoult's law. Right? Okay. Anyway, Raoult's law. Under Raoult's law, we are going to prove an equation which you can use it in your exam without proving it. The proof is difficult, right? This is I think the most difficult proof in your syllabus, right? This is the most difficult proof in your syllabus. It's long and you need to make few assumptions and it's wrong. I'll give you a chance to figure out what's wrong. The reason for that is we use a simplified version which is not the exact equation. The exact equation is more difficult. That's why. We are making an assumption which is wrong. Then somehow this is the most difficult proof and therefore we thought that this won't be asked in A-levels. Generally when I was a student I thought that this won't be asked in A-levels. But when I was for my A-levels, this was given in 2020. This was given to prove Raoult's law. Luckily, I knew how to prove the law, but most of the students did not because this is difficult. Will ignore the proof and then they will just follow the question or the calculations. The calculations are really easy. Therefore, most of the students opt to do the Raoult's law questions in A-levels because considering the other equilibrium questions, this is one of the easier one, right? But in our A-levels, most students didn't do actually the Raoult's law question because the first part was prove the Raoult's law and anyone with a brain at that point knew that for that part there was a significant number of marks allocated because that's a difficult one. Now if the question was for 75 marks, at least the proof was for 30 marks. This is not like a normal proof which they give 5 marks. This is a longer one. But you need to somehow understand it. Otherwise, if they give the Raoult's law proof again, then you won't be able to do the Raoult's law question because the question itself is really easy. Right? Okay. Then let's start the proof. Right, okay. Now this is the solution. Pay close attention now. This is the solution which contains both the liquids, right? Which contains both the liquids, which is A liquid and B liquid. And then after a certain amount of time, some amount of this liquid will be vaporized. If you are interested on how that vaporization part is happening, we will learn that under phase equilibrium, right? We will learn that under phase equilibrium. Somehow it's going to vaporize and then it will become A gas, this will become B gas. This is known as the vapor phase. This is known as the liquid phase. Vapor phase, liquid phase. And there will be an equilibrium between there will be an equilibrium between A gas. Right? These are the equilibriums. Right? I am only considering this part because this is entirely same like this. So I'll do the proof for this, then you can write this looking at the proof for A. Harida? Let's consider A. Considering A. Considering this equilibrium. A liquid, equilibrium, A gas. This is the equilibrium which we are going to consider. So you have the basic idea on what we are looking at and we are considering this part to derive the equation. Hari. Let's take the forward reaction as RF and the backward reaction as RB. right? So RF is A liquid goes to A gas and RB is A gas goes to A liquid. It's clear, right? It's just general chemistry. Then you can write RF is A liquid goes to A gas. I am going to break down this equilibrium into two parts. This is the first part. A liquid goes to A gas, and then shall I write it here or later? I'll write it here. A gas goes to A liquid. This is right. We'll just try this. Now this is what? This is RF. A liquid goes to A gas is RF. This is RF, right? RF. Is it clear? This is RF. Hurry. Now what I am going to say is that the rate of RF is proportional to what? Tell me. Now you have done kinetics, right? You know kinetics. Using your kinetics knowledge, tell me. Now if you haven't done kinetics, just ignore it for the moment. If you have done kinetics, tell me this RF should be proportional to what? It should be proportional to what? Now if we have a reaction A plus B goes to P, then you can say R is equal K times A to the power A, B to the power B, right? Which means R is proportional to A to the power A and it's proportional to B to the power B. Is it clear? Harinel? Okay, looking at this, tell me R is proportional to what? R is proportional to what? Yeah, exactly. It's proportional to the concentration of this, right? It's proportional to the concentration of this. Therefore, it's proportional to A liquid concentration to the power of A. Or else you can straight away write it as, no, we'll keep it like this. But here we are going to assume that this A is 1. We are simply assuming that this equation is elementary. We are assuming that this equation is elementary. Now, if you don't know what elementary is for the moment, if a reaction is elementary, then this number will be equal to the stoichiometric coefficient here. So the coefficient is 1, therefore this is 1. Then it's simply you can erase this. It's just this. Right? It's just this. So RF is directly proportional to A liquid. Now we are going to find another let's say another component which is proportional to A liquid. Now we know that RF is directly proportional to A liquid. Now what we are going to do is we are going to find some another component which is actually proportional to A liquid. Which is, now tell me, now here, right? If you increase the concentration of A liquid, right? If you increase the concentration of A liquid, how are we supposed to increase the concentration of A liquid? By adding more A, right? What will increase? Try to tell me. If you increase the concentration of A liquid, what else will increase? Here make increase according to your knowledge in chemical calculations. If you add more A, if you increase the concentration of A liquid, then what will increase? Increase here. I want your participation because this is difficult. This might take some time. Hurry. What will increase? No, I'm not talking about anything here. I want what is increasing in the liquid phase. Don't think about the vapor phase. We will talk about that later. If you increase the A liquid concentration, what will increase in the liquid phase? Liquid phase increase. Okay, the number of molecules will increase. Yeah, I'm talking something like that. The number of, not the rate, not something kinetic, right? I am talking about the chemical calculations. If you increase the A liquid concentration, its number of moles, but then both are the same. If you, so to increase the concentration, you need to increase the number of moles. That's not what I am talking about. Okay, if the A number of moles are increased, now if you increase the number of A moles, then what will increase? Increase after the number of moles in a solution, what do we talk about? What do we talk about? No, not the mass. That's not what I want. No, after moles, if the number of moles increase, then what will increase? All your answers are correct, but that's not what I want. If you increase the number of moles, what else will increase? It's not a property, it's a term. It's not a pressure or a volume, it's a term. If you increase the number of moles, then what will increase? Now you will understand. If you have a sample with, let's say, 5 moles of A and 3 moles of A, I will add another 2 and I have 7 and 3, then what will increase of A? That there is no order. If you had a sample of 5 A moles and 3 B moles, then you added 2 more moles of A, then you have 7 and 3, then what increased? What increased? The molar fraction, right? Got it, finally. That's the molar fraction will increase, right? Therefore, we are saying that the concentration, if you increase the concentration of A by adding A liquid, then the molar fraction of A will be increased. The molar fraction of A will be increased, right? Therefore, I am going to say that Rf is proportional to the molar fraction of A in the liquid phase. Now you might be wondering, how do you know by looking at this that this is the molar fraction of A in the liquid phase? Because we have a vapor phase, in this part, since we have A in both sides, the molar fraction in this vapor phase is normally denoted as Ya. The molar fraction of A is Ya, molar fraction of B is Yb. Those are not standard notations, but we generally use that. Here for the molar fractions in the liquid phase, we use Xa and Xb. Right? This is Ya and Yb, which we will use later. Right? Idea. Now what we did was, we understood that when you increase the number of moles, increase the concentration of A liquid, the molar fraction also increases. Therefore, we assume that the concentration of A liquid is directly proportional to Xa. Using this relationship, instead of A liquid, I can write this. Again, this is proportional to this and this is proportional to this. Therefore, I can say this is proportional to this. Check whether that's understandable. It's complicated. This is the most difficult proof in your syllabus. Then, I am going to write Rf is equal to, let's say, Kf times Xa. I am simply removing the proportionality by adding a constant. This is the first part for the forward reaction. This is the first part for the forward reaction. Is it clear? May forward reaction එකේ කතාව. Hari. Okay. Then I'll continue, right? Backward reaction එකත් කළා, we'll write. After the backward reaction also, we'll have to rearrange few more terms. So where did we start? කොහෙන්ද අපි පටන් ගන්නෙ? Here we got an understanding on how the system looks, and I considered only this equilibrium. So this is the equilibrium. So I wrote down that this is the forward reaction. This is the forward reaction, and we assume that this reaction is elementary. Therefore, I can say Rf is directly proportional to Al instead of this A. I assume that this A is 1 because this reaction is elementary. Then I can say Al is directly proportional to the molar fraction of A in the water phase, the liquid phase. Then I can say this, then I can say this. Hari, we'll write all the assumptions and we'll create a complete note later. Hari, make a That's it for the forward reaction. Then I'll consider the backward reaction. What's the backward reaction? The backward reaction is A gas goes to A liquid. That's the backward reaction. The backward reaction is A gas goes to A liquid. This is the backward reaction, right? A gas goes to A liquid. This is the backward reaction. So it's RB. Then what do I know? The same thing. I am going to repeat the same thing. That RB is directly proportional to what? A gas. Concentration of A gas. Is it clear? The same thing. RB is directly proportional to concentration of A gas. Then tell me this. Again, we are going to find another property or another term which is proportional to A gas. What is proportional to A gas? Now, if you increase the concentration of gas in the vapor phase, what will increase? Kaling විදියටම හිතන්න බලන්න. Kaling විදියටම try to repeat. Kaling විදියටම හිතන්න. If you increase the concentration of gas in the vapor phase of A, what of A will increase in the vapor phase? Now for the liquid phase, if you increase the concentration of A, the molar fraction increased. Hari. Here what will increase? Another term, not the molar fraction. The molar fraction will definitely increase. That's not what I want. Here another term will increase. What will it be? If you increase the concentration of A, that means you add more A gas. Then what will increase? If you have more A gas, yeah, the pressure will increase, or the partial pressure of A will increase. Therefore, I can say that the concentration of A gas is proportional to the partial pressure of A. If you add more A gas, then the pressure of A will increase, right? Then I can say R, sorry, no, right, I can say RB is proportional to PA, then I can say RB is equal to K2 times PA. I just added the constant. Sorry, not K2, we will say KF, KB, KB, right. So we have two equations. RF is equal to KF times XA, sorry, yeah, and XA, no need to put a square bracket. Then square bracket square bracket is for concentration, it's just XA here also. Right, the molar fraction. Then we have this. Right, we'll write this up to now, then we'll continue. So start from here, draw a small sketch on what we are talking, then consider only this equilibrium. This is the same, we'll only consider this equilibrium. This is the vapor phase, liquid phase, we'll only consider this equilibrium. Then write down this. You can either consider this as the forward, it doesn't matter, right? You can say A liquid goes to A gas as the backward reaction as well, doesn't matter. You can switch it. But here I considered A liquid goes to A gas as the forward reaction and this as the backward reaction, right? So consider those two and then come up to this point for the forward reaction. ටක් ගාලා එන්න බලන්න. මේ රූපය අඳ ගන්න මුලින්ම. කරගෙන යන්න ටක් ගාලා. Always try to understand it and write. I'll minimize, then you can see a little bit more. If you can't see, just let me know. පේනවා නේද shape එක අවුලන්නේ නේද? ඔය ගන්නට තියමු. හරි දාගන්න බලන්න. හරි. Always try to understand and write down this, right? Otherwise I could have just give you the note and tell you to understand or just remember this. නිකන් මතක තියාගන්න කියන තිබ්බනේ, because this is not necessary for questions. But I am spending a lot of time just to make sure that you understand what's happening here, right? තේරුම් අරන් ලියමු. මෙතන මේ elementary කතාවත් ලියාගන්න. Since this is elementary, I am considering this A as 1. Therefore, I can directly say that RF is proportional to A liquid. Directly this. The power of here is being 1. හරි ඒව තේරුම් අරන් ලියන්න. Then I am considering this relationship. Then using this, I am considering this. If you want for this, you can write a side note. By increasing the amount of liquid of A, the molar fraction of A in the liquid phase will increase. This is the molar fraction of A in the liquid phase. X කියන්නේ liquid phase එකට, Y කියන්නේ vapor phase එකට, or the gas phase, right? Then you can put a proportionality constant and then get up to this point. එන්න බලන්න. If you have doubts, ask. Write everything, because later when you go through the note, you might not remember everything. Therefore, write everything. Okay, I'll answer that question later. Hurry. Now this is for the backward reaction. This is for the forward reaction, and for the backward reaction also again this is assumed as elementary. Then again the power here is 1. Then we assume this is another proportionality using the understand in the practical scenario. If we increase the concentration of gas A, then the partial pressure will increase. Therefore you can use this, write this, and then write this. We will start electrochemistry on next month. April we will start electrochemistry according to our plan. Okay, this is okay. Now what do we normally do? Since this is an equilibrium, you know that the rate of the forward reaction and the rate of the backward reaction should be equal. Is that clear? Now you can write, since this is an equilibrium, you can say Rf is equal to Rb. Rf is equal to Rb. Then what I am going to do is, normally we write the equation the other way. Right? You will understand why later. Here I will write that Rb is equal to Rf. Doesn't matter. I just write like this. Then it's Kb times Pa equals, what is Rf? Kf times Xa. Now I am going to subject Pa. Then I will get Pa is equal to Kf divided by Kb times Xa. Is this clear? Since considering the equilibrium, this. Step by step in. Now this is a constant. We need to find the value of this constant, right? Now we need to find the value of this constant. Normally, now finding the value of this constant needs to be understood clearly. Now if you have a graph y equals mx, right? If you have a graph y equals mx, how do you normally find m? How do you find m? Don't send me delta y over delta x. That's not what I want. What's the procedure? What do we use to find m? Monada we use karanne. Now they have given you a graph, and then you are supposed to find the m. I'm not asking the meaning of m. I know that m is gradient. Okay, now that's not what I'm asking. What do we use to find m? Monada we pavichchi karanne to find m? In any graph, to find the m, we use different points, which we know, right? For any graph, to find any unknown term, we use 1 or 2 points which we know. That's the concept. Api graph එක කරන්නේ අපි දන්න points. We'll consider the points which we know, and then using those we will get the unknown value, right? Here also we are going to find the value of this unknown constant, because this is a constant which we added. Kf and Kb are constants which we added. Those are not proper constants. We need to find a proper value for this constant. That's what we are going to do here by using the things which we know about this system. Now we need to understand, we need to check with what we know about this system, right? This needs to be understood clearly. Tell me tell me this. Hari. I don't know whether you know this, that's why I am checking. Now in heat, in the 4th unit of physics, you will learn, you have learned this. Let's see whether you can remember. We will learn this concept which I am going to teach you under phase equilibrium, but in chemistry we haven't learned this. In physics you have already learned this. If you have a solution which only contains one liquid, let's say only one liquid, that will form a vapor phase. The pressure of this vapor phase will be equal to what? Does anyone know? If you have a liquid, a single liquid, not a system, only one liquid, and that forms a vapor phase, the pressure of that vapor phase is equal to what? Right? No, not atmospheric pressure. Yeah, it's atmospheric pressure, but it's again equal to what pressure of A? Does anyone know? It's known as this pressure of A. What is it equal to? Not atmospheric pressure. Okay. Others? If you have only one single liquid now, in physics, in the 4th unit, you normally don't consider about atmospheric pressure. We have a special name for that pressure. If you have only one single liquid and that forms a vapor phase, right? That forms a vapor phase. That pressure in that vapor phase is known as a special pressure of A. What's that pressure? Okay. Others? මතකද 4th unit එකේ තියෙන්නේ. If you have only one liquid, that pressure is known as the saturated vapor pressure of A, which is denoted like P naught A in chemistry. P naught A. Oh, this naught is superscripted and A is subscripted. හරිද? P naught A කියලා තමයි ලියන්නේ. Is it clear? That's the saturated vapor pressure. හරි. Now, using this knowledge, what do we know? I repeat, if you have only one single liquid in a solution, then that's not a solution. If you have only one single liquid, the vapor phase which is built on top of that liquid phase, the pressure of that vapor phase is known as the saturated vapor pressure of A. If we learn more about saturated vapor pressure, if you can't remember what is saturated vapor pressure, how do we know whether that's exactly saturated vapor pressure, and then there's the boiling point concept. We learn in phase equilibrium, and you might have learned under physics, I don't know. But here, you just need to know that's known as the saturated vapor pressure. That's the maximum pressure which it can achieve at that given temperature. මේ temperature එකේදී ඒට තියෙන්න පුළුවන් maximum pressure එක වගේ idea කියලා දැනට හිතන්න for the moment, right? That's saturated vapor pressure, right? Now using this concept, tell me for this scenario what is XA? For this scenario what is XA? කියන්න බලන්න මේ scenario එකට XA කීයද? We only have A. Then what's XA? The molar fraction of A in the liquid phase is 1. Is it clear? Right, good. Then what is the pressure? What is the partial pressure of A? The saturated vapor pressure. The pressure, so for this system, when XA is equal to 1, PA or the pressure of the vapor phase is equal to the saturated vapor pressure. This is what we know. Using what we know, we can find the unknown term. So for this, if you substitute various XA values, you will get various PA values. We don't know those, right? අපි ඒව දන්නේ නැහැ. But we know only one point. අපි මේ graph එකේ එක point එකක් දන්නවා. That point is when XA is equal to 1, PA should be equal to P naught A. That we know. Now we are going to substitute it here. අපි ඒක substitute කරන්න යන්නේ. තේරෙනවනේ මේක ටිකක් තියනවා depth එකක්. හරි? We are going to substitute it here, right? Then substituting this situation, PA is equal to P naught A when XA is equal to 1. This part we don't know. Then you can see we have got a value for this fraction. Kf over Kb is actually equal to P naught A. This is a constant, right? This won't change. Only this and this will change. Now the similar thing you do for y equals mx. If you know the equation is y equals mx, if you know one x value and one y value, by substituting these you will get the m. Same here. We knew one xa value and we knew one pa value. By substituting those you can get the value of kf over kb. Then you get kf over kb. Kf over kb. Kf over kb is equal to P naught A. we got the answer for the constants which we didn't know. Then you can rearrange the equation. PA is equal to P naught A XA. This is the final equation for, this is the final, or this is the Raoult's law equation. This is the Raoult's law rather, right? So this is, we came up to this point. After this point, you need to explain this situation. May point again passe, you need to explain this situation. What do we know? You can put a side note and say, if you have one single liquid in a container, then the vapor pressure for that single liquid is the saturated vapor pressure for that substance. A liquid විතරයි නම් ඉන්නේ, the pressure in the vapor phase is equal to the saturated vapor pressure. Therefore, you can say if XA is 1, when we have only one substance, the molar fraction will be 1, right? එයා විතරනේ ඉන්නේ, then the molar fraction is 1. And the pressure will be the saturated vapor pressure. By substituting these two data into this equation, by plugging these two equations, you can get the value for the constant. Then plugging that constant here, you can get the equation. බලන්න එක තනියෙන් කරගන්න පුළුවන්ද කියලා. If you have doubts, you can ask. බලන්න whether you can get it. Right. මේක clearly ලියා ගන්න. Just don't plug 1 and P naught, then you don't know how you got it. නිකන් resource book එක වගේ නේ. ඒකෙත් කියලා නැහැ කොහොමද එන්නේ කියලා. I gave you the idea. ගන්න බලන්න. If you want guidance, put it on the chat. Hurry. Once you get up to this point, you can write, now this is for A, right? This is for the equilibrium of A. Then you can say, this is also true. For equilibrium of B, you can say that PB is equal to what? P naught B XB. The same idea, right? PB is equal to P naught B XB. A වලට මෙහෙම නම් B වලට මෙහෙම කියලා ලියද හැකියි, right? PA is equal, no, that's the theory. This is not the Dalton's partial pressure. This is the theory. In physics you learn, in chemistry also later you will learn, if you only have one liquid, the vapor phase pressure of that liquid will be equal to the saturated vapor pressure. That's a theory. That's not nothing to do with any calculation. නිකම්ම theory එකක්. එක liquid එකයි නම් තියෙන්නේ, the vapor phase pressure is equal to the saturated vapor pressure, which is the maximum pressure which we can achieve for a given substance. තනියෙන් ඉද්දි එහෙම තමයි. Now if you take a water container and if you observe a vapor phase of water, then the vapor pressure, the vapor pressure of that vapor phase is equal to the saturated vapor pressure of water. එහෙමයි වෙන්නේ ඒක. The maximum pressure. මොකද vaporize වෙන්න පුළුවන් maximum එකම vaporize වෙනවා. ඊට වඩා vaporize වෙන්න බෑ. That's why. Right? That's a theory. මේක theory එකක්. This is theory. When XA is equal to 1, P is equal to P naught. මේක නෑනේ Dalton's partial pressure එකේ. Saturated vapor we don't have. That's not the total pressure, that's the saturated vapor pressure. Does anyone know how to confirm this? Now if you know physics, if you know that humidity part or heat වල තියෙන part එක, then tell me how can you confirm this, that this is saturated? How do we confirm that a vapor phase is saturated? කොහොමද confirm කරන්නේ? Does anyone know? Physics වල තියෙනවා basics මං හිතන්නේ. Does anyone know? How to confirm? Now you observe a vapor phase for any substance. How can we confirm whether that is saturated or not? If it is in equilibrium with water, if it is in equilibrium with the liquid of that substance, then it's saturated. How do we know? Yeah, so that's the answer, the presence of the liquid. If you see a vapor phase, if it is in equilibrium with a liquid, so basically if it is present with a liquid, then we know that the vapor phase is saturated. Okay, that's what we used here. How do we know? How is it possible? If we have a vapor phase with a liquid, then how do we know that vapor phase is saturated? Again, the maximum has been vaporized. How do we know? Oh, පුළුවන්. මේක prove කරන්න ඕනේ නැහැ. Similarly, for PB you can write it directly. No need to prove it again. Okay, but how do we know? I didn't exactly get the answer. Now you have මම පොඩ්ඩකට switch වෙන්නම්. Now you have let's say a vapor phase. Now you have this vapor phase. මේ vapor තියෙන්නේ. You have gas here. I want to check whether this is saturated. The easiest way is that if the vapor is present with a liquid, if we have a liquid here which is in equilibrium, then you can directly say if you have only one liquid, this is for only one liquid, right? Not for a system. System එකට අපි දැන් prove කරානේ that. Then you can use the Raoult's law. This is only for a system with one liquid. If you have only one liquid, then I am directly saying that this is saturated. How do you know? කොහොමද කියන්නේ කෙලින්ම that this is saturated? If this is not saturated, what will happen? Assume that this is not saturated, which means it can get more vapor. Then how can we see a liquid? Then it should vaporize. If we have a liquid here, which means the maximum amount of vapor has been contained, has been absorbed or has been stored here. If you can store more vapor, then how can we have a liquid? Then it should be vaporizing. තව vapor maybe මේක නැති වෙලා යන්න ඕනේ. If you have a liquid with a vapor phase, which means the maximum amount of vapor has been stored, that's why that liquid is remaining. Liquid එක ඉතුරුලා තියෙන්නේ මේ ඔක්කොම ගන්න පුළුවන් උපරිම ටික අරන් නිසා. තේරෙනවද? Therefore you can confirm that this is a saturated vapor, right? Those are concepts which you are supposed to learn in the 4th unit under heat. Hari? Not here. Right. So you can write this, and similarly you can write this down. No need to prove it again. Right. එන්නකො බලන්න. We took, I guess, 45 minutes to prove this. දන්නේ නැහැ කොච්චරලා ගත්ත කියලා, doesn't matter. Ready? Is it clear? Now we'll write this equation. Now this is the equation. Now this is not Newton's second law, right? This is the equation for Newton's second law. I can't remember. I think it's the second one. Anyway, this is the equation. This is not the Newton's law. Law is written in words. This is the equation. Now this is not the Raoult's law. This is the Raoult's law equation. Now we will write this in words. Then that will be the Raoult's law. For 90% of the questions, this will be asked, and most of the parts of that question can be done only using this. මේක විතරයි ඕනේ වෙන්නේ. Few more equations which you know කලින් දන්නේවා ටිකක් තියෙනවා. We'll learn those later. So write down the Raoult's law. Put a star mark and write the Raoult's law. Okay, clearly write it. Partial pressure of a given component. Partial pressure of a given component of an ideal solution. Partial pressure of a given component. This is this, right? Partial pressure of a given component of an ideal solution. මේ කතාරන ideal solutions නේ. Partial pressure of a given component of an ideal solution. In brackets, open brackets, and write under constant temperature, which we need to mention, right? In brackets, right? Under constant temperature, close brackets. Partial pressure of a given component of an ideal solution, open brackets, in constant temperature, close brackets, comma, is equal to the product of is equal to the product of saturated vapor pressure of that substance. Saturated vapor pressure of that substance. To the product of saturated vapor pressure of that substance. And the molar fraction of that substance in the liquid phase. Saturated vapor pressure of that substance and the molar fraction of that substance in the liquid phase. Right? Is it clear? Right? Is it clear? If you want me to repeat, put it on the chat. So that the definition is not written anywhere. I just wanted to be I just wanted to check whether I'm telling it properly. I'm value single leap definition in the resource book. But you can simply write the definition by looking at any equation, right? Only you need to know the terms which is not given in the equation. Now in the equation there's nowhere which they have mentioned about the temperature. Therefore you need to know that you need to write in constant temperature. Apart from that, everything is given on the equation. You can say, and also the ideal solution part which is not given here. You need to remember that this is for an ideal solution and this is under constant temperature. So simply the idea is, for an ideal solution under constant temperature, if you want to calculate the partial pressure of a given substance, which is A for this equation, that is given by the saturated vapor pressure of that substance, the product of saturated vapor pressure of that substance, and the molar fraction of that substance in the liquid phase. You just need to know that this definition is given, this equation is true only if the temperature is constant, which is generally normal for any equilibrium, right? Otherwise everything will change. The temperature should be constant, and this is only for ideal solutions. That's it. It's alright. Therefore, no need to remember those laws. You can just write this equation, and then looking at that you need to be able to derive it. Okay, so that's it. And here I won't go into detail, but I'll just mention that this is wrong. If you are interested only, you can check, otherwise just ignore it. Even myself understood that this is wrong when I was doing classes, right? Even when I was writing my LOs, I didn't know that this is wrong. One student questioned me, then I went into further details, and then I found that this is a simplified version. That's why this is wrong. This assumption is wrong, right? You can think why later if you want. That's not necessary. That the concentration of A liquid is not proportional to the molar fraction of A. You can think why later if you want. Right? If you have ideas, you can ask me. I'll explain later. Not here, right? Because this is complicated, and no need to make it more complicated trying to understand few things. But if you are interested, if you are comfortable, you can think. I always encourage you to think if you can. Then the fifth one. That's the proof. Is it clear? Is the proof clear? Okay, I'll give you 1 minute. Quickly read the proof. Check whether you can understand. I took a lot of time I simplified this proof. මම ගොඩාක් ලේසිකල්ලි ඉගෙනුවේ. Check whether you can understand it. And after today's class, today or tomorrow, try to do the proof by your own, right? On your own. තනියෙන් කරන්න බලන්න without looking at the book. It's difficult. It's not easy as it seems, right? When you want to learn a proof, if the proof is difficult, you can't just go through your note and think, okay, I can understand it, therefore I can write it in my own. No, that won't happen. You need to write it. එකපාරක් තනියෙන් ලියන්න ඕනේ, then you will understand. Then you will remember. හරි? හෙට හරි අද හරි එක කරන්න. Okay. Take 1 minute. බලන්න මේක දිහා. Right. Is it clear? අවුලක් නැහැනේ. Then using that equation, we need to know two more terms which I'll give you as a question. හරි? Q කියලා දාලා ලියන්න. Put a Q and write. This is actually a theory part, but we'll write it as a question. Calculate the decrease in vapor pressure. Calculate doesn't matter. Calculate the decrease in vapor pressure and calculate the decrease in vapor pressure and the relative decrease in vapor pressure. Relative decrease in vapor pressure. Calculate the decrease in vapor pressure and relative decrease in vapor pressure when a binary solution is formed. When a binary ideal solution is formed. Calculate the decrease in vapor pressure and the relative decrease in vapor pressure when a binary solution is formed. When a binary solution is formed. Is it clear? What does that mean? Decrease in vapor pressure. Read the question again. Decrease in vapor pressure is, now if we consider a system which it contains only a liquid, then what will be the vapor pressure? The vapor pressure will be P naught A, or the saturated vapor pressure. Is it clear? It will be P naught A. When you add another component or another liquid, then it will become a ideal binary solution, A liquid and B liquid. Then there will be a vapor phase for both A and B. Then the pressure of A is given as PA. It's not P naught A, right? It's not P naught A. How do we know? Because we know the equation now. It's this. Now the equation for pressure of A is PA, which is equal to P naught A times XA. So it's not directly equal to P naught A. It's something which should be multiplied by the molar fraction on that of that time, right? So it's not PA, P naught A. So it's just a partial pressure which is PA. Now this is the initial stage. We only had A liquid. The pressure was P naught A. Then we added another liquid. Then the pressure dropped to PA because this is the maximum value. We know this should be less than this. This is less than this. Then the decrease in vapor pressure is the difference. How much did the pressure decrease? Simply they are asking the difference between P naught A minus PA. Right. So what I want is another equation, another way which you can express this equation. That's what I want. I want you to express this decrease in vapor pressure in another way. How can I express this? Tell me. I'll write. This is just a theory, right? When you can theory with you just need to know how to manipulate these equations. That's it. Instead of P naught A, I won't do anything. I'll just write P naught A because it's P naught A. Instead of PA, I am going to write P naught A XA. Is this true? Instead of PA, I wrote P naught A XA. What is P naught A XA? It's the Raoult's law, right? PA is equal to P naught A XA. That's what we proved. Dharmahansela prove karega PA is equal to P naught A XA. Then what can I do? Then I can factorize P naught A. Then I will get 1 minus XA. Does anyone know what is 1 minus XA equal to? What is XA? XA is the molar fraction in the liquid phase for A. In the liquid phase, right? Not the vapor phase. Then it's YA. What is 1 minus XA equal to? Okay, others? What is 1 minus XA equal to? Everyone try to answer. හැමෝම උත්තර දෙන්න බෑ හොරට ඉන්න එපා. මේක උත්තර දීලා මහන්සිලා වරද්දලා හදා ගන්න ඕනේ. Yes, 1 minus XA is equal to XB, right? Because we know we only have two substances. Since we have only two substances, XA plus XB should be equal to 1. That's basic chemical calculation knowledge. Then 1 minus XA is equal to XB. Therefore, you can write P naught A XB. No need to memorize these equations, but you need to be able to prove these equations. In MCQs, they will ask questions, then you need to know. Now they will ask something like this. If you don't know this, you can't even imagine such a thing, right? Now they will ask, the pressure decrease of A or the decrease of pressure of A is equal to the product of the saturated vapor pressure of A into the molar fraction of B in the liquid phase. Doesn't make any sense, right? The decrease of pressure is equal to the saturated vapor pressure of A and the molar fraction of B in the liquid phase. Not even A, it's B. එකපාරට B එක ගැලපෙන්නේවත් නැහැ වගේ. It doesn't make any sense, right? Because it's just a term which we derived using an equation. මේක කිසිම අර ඒක දැනෙන්නේ නැහැ. We don't feel it, right? How did a B come here? මෙතන B එකක් ආවේ කොහොමද කියලා හිතලා you think it's wrong. But you need to be able to derive this equation if they ask for the pressure decrease, right? Okay. So then as the answer you can write, you need to first explain, this is the first part, you need to explain what does this pressure decrease mean. This is the initial stage, you only have one liquid, therefore the pressure is P naught A. Once you add another liquid, the pressure will decrease to PA. The decrease between the vapor pressure means this, P naught A minus PA. So you can explain it and then start writing your answer for the decrease of pressure. Then you can derive it and get the answer. Okay. That's for the first part. Write down this. බලන්න තේරෙන්නේ නැත්නම් අහන්න. නිකන් ලියන්න එපා. You need to understand, right? Done. If you are done, try to write an answer for the relative one. Try to understand what's relative decrease in vapor pressure. Right. Clear neda? Is it clear? I'll give you 30 seconds. Always make sure that for the moment X is the molar fractions in liquid phase. Y is the molar fractions in vapor phase, but that's not standard, right? If you see XA, it's not definitely in the liquid phase, but for the moment in our notes, it's like that, right? In a question, it can change. Decreasing in vapor phase. Yeah, exactly. Yeah, correct. Now you need to write another. Now you understand the concept for relative decrease. Now you need to write an equation for that. So we just need to write one more step, then you can get it. Okay, I hope this is okay. Then let's try to answer the next part. What's the next part? Relative decrease in vapor pressure. Can someone give me an equation? Now this is decrease in vapor pressure. What is relative decrease in vapor pressure? Does anyone know what's relative decrease in vapor pressure? Any answers? Any answers? Relative decrease in vapor pressure. Good. Others? What is relative decrease in vapor pressure? මොකද relative decrease in vapor pressure කියන්නේ? හොඳයි. Now for the students who don't understand how to get a relative ratio, we'll talk about a general scenario. නිකන් මේවා නෙමෙයි. Now if you listen to news, you can generally යන්නේ මොනවද? The price of bread was increased by 20%, or price of petrol was increased by 20%. Now let's assume that the price of bread is 100. නැත්තම් කැත ගාණක් ගමු 100 පොඩ ලස්සනයිනේ. Let's say it's 80. This is the initial price. Now it was increased by, let's say, and the final price was 110. Since we are talking about a decreased scenario, we'll talk about a decreased one. Let's say the price of bread was 110 and now it is 90. Never happens, but hitamuko is 90. The initial price and this is the new price. Then what's the decrease? The decrease is simply the difference, which is 20. We subtract the smaller number from the higher number, then it's 20. But normally in news, they won't just say the amount, they will give you a percentage, then you can understand it better, right? So what do is we get the difference and divide it by the initial one, not the new one, right? We'll divide it by the initial one, then we'll get a percentage. What's the difference relative to the initial value. So you get the difference and divide it by the initial number. එහෙමනේ කරන්නේ bus prices වැඩි වුණා කිව්වම if it is increased from 20 to 23, then the percentage is 3 divided by 20. The difference divided by the initial value. For a decreasing event also the same. The difference is 20 divided by 110. This is the percentage or the relative decrease. Here also the same thing. I think same concept. Hari, science is nothing new. Hari, nothing different. Hari, here also this was the pressure decrease. P naught A minus PA. Initial pressure minus the final value. Initial pressure minus the final value should be divided by the initial pressure. It's P naught A. This is the relative decrease of pressure. You know that this part, this part is equal to P naught A XB. We derived it previously, divided by P naught A. Then these two will get cancelled and it's simply XB. So the relative decrease of pressure for a liquid is equal to the molar fraction of the other liquid. Doesn't make any sense, right? But that's true. So if you want, you can write down this concept. The relative decrease is the difference divided by the initial pressure. Doesn't matter. Somehow you need to understand it. Right. Then we'll have a small interval. Right. If this is clear, fine. If it's not, put it on the chat. Hurry. It's 8 minutes past 10. We'll start at 10:20. We'll start at 10:20 and continue until 11:40 roughly. 11:40 again karamu. Most of the theory parts for non-ideal solutions are finished. We'll continue from the next theory. Right? Put graphs tika, prasthara tika kanina thi. Right. Then join the meeting at 10:20 sharp. Hurry. Okay. If you have questions, put it in the chat. Right, okay, you can hear me, ne? Hari. Then let's continue. I gave you 5 extra minutes. Hari. මොකද්ද මේ? හරි. Then okay, we have 2 more topics which is regarding few graphs. අපිට පොඩි graphs වගේක් අඳින්න තියෙනවා. හරි. පොඩි graphs වගේක් අඳින්න ඕනේ. දැන් මෙතන වෙන්නේ before we go draw the graphs, I'll show you how to no, actually I'll show you what equations it's you need to use to do a small calculation regarding or shall we do it later? Yeah, never mind, we'll do it later. So we'll straight away start drawing graphs, then you will understand. So we'll finish theory in another 30 minutes, then I'll start doing questions. Theory means theory regarding ideal solutions. Then we have a small part regarding non-ideal solutions, and we have fractional distillation. If you can remember fractional distillation, which was for your O levels, we learn how that concept can be used here. Right? We'll do those later. Hari. Somehow write another main topic and write. Put a main topic and write vapor pressure composition diagram. Vapor pressure composition diagram. Composition diagram. Vapor pressure composition diagram. Hari. Vapor pressure composition diagram. Right. Now what happens here is, now looking at this equation, looking at Raoult's equation, still we are doing ideal solutions, non-ideal karanne poddai. Looking at this equation, you understand depending on how much of A and B we have, if we change the amount of liquid in A and change the amount of liquid in B, the molar fraction of A will change, right? This is a constant. Now we are considering a system for a given temperature, right? For a given temperature, P naught A is a fixed value for a substance, right? Now let's say water. For water at 100 Celsius, P naught A is a constant. For water at 50 Celsius, P naught A is a constant. Therefore, this is a constant. This won't change. We are considering only one temperature for a time. Then, if you change XA, depending on that value, PA will change. If we change XA, then XB will change. Why? Because XA plus XB is equal to 1. If you change XA, then XB will change. If you change XB, then PB will also change. Neither. If you change this, then this will also change. Harned. If you change this, this will change. If you change this, this will change. Then this will change. If you change this and this, what will change? The total pressure will change. Now this is the next equation which we are using here. This is the Dalton's partial pressure equation, which is in the 4th unit. I gave you the opportunity to complete the 4th unit. If you couldn't join, you can either get the recordings if you want. Hurry, send me a message, then I'll send you the recordings. We are finishing the gas laws unit for 2026 batch tomorrow, the English medium class, right? So here the total pressure will also change because A and B change. So altogether you get the idea. If you change the molar fraction of one component, then the partial pressures of both components will change. Also the total pressure will change. Therefore we can draw a graph. The x-axis will be the molar fraction and the y-axis will be the pressure. You can draw three graphs. One is for the partial pressure of A, one is for partial pressure of B, and then for total pressure. So you can draw three graphs in one xy coordinate plane. Harida theranawada? Right. Then we'll see how the graph will look like. It will look like this. We have two y axes. You will understand why. Me kelling andinna kathai meka lassan taminti. The x-axis is the molar fraction of A. Let's say it's molar fraction of A. So it's 0 here, it's 1 here. Do we need to write molar fraction of B? It's not necessary. Why? If you want, you can write, but it's not necessary because we know if xb is written, if xa is 0, then xb is 1. If xa is 1, then xb is 0. Let's say xa is 0.3 here, then xb is 0.7 here because the sum should be equal to 1. Therefore, no need to even write this line, but if you want, you can write. Doesn't matter. So for the moment I will just erase it because it looks complicated when you have two rows. Here this is pressure, and this is pressure. And pressure දෙකක් තියෙනවා. Now using the equation for PA and PB, I am going to write PA is equal P naught AXA. Right, now I'm going to ask few questions. Tell me, when XA is equal to 0, PA is equal to what? Now what is now, you just, it's not just substituting, right? You need to understand what we are doing here, right? XA is the molar fraction of A in the liquid phase. P naught A is a constant which is the saturated vapor pressure. PA is the partial pressure in the vapor phase, right? Pressure එකක් තියෙන vapor නේ, the vapor phase, right? If I draw you a diagram, now this is the binary liquid solution. We have A liquid and B liquid. The amount of A liquid is given as the molar fraction of A. This is the molar fraction of B, XB. And here we have A gas. The pressure of this A gas is given as PA. The pressure of this B gas is given as PB, right? And it's not just substituting the equation, right? You need to understand what's happening here, right? What we are talking about, you need to understand. Yes, when XA is equal to 0, its PA is equal to 0. Therefore, I can mark it here. When XA is 0, P is 0. Pressure is 0. We are drawing the graph for A. So no need to mention PA. We are drawing the graph for A. This graph is for A. Okay. When XA is equal to 1, PA is equal to what? When XA is equal to 1, PA is equal to what? Yes, P naught A. If you substitute 1 here, then you will get PA is equal to P naught A. It's just a random value. Let's mark it here. P naught A. Is it a curve or is it a straight line? Now you know two endpoints. Is it a straight line or is it a curve? If it is a curve, y. If it is a straight line, y. I need a logic. හැමෝම answers දෙන්න try කරන්න. නිකන් ඉන්න බෑ. I want answers. I want logics. කියන්න බලන්න. Is it a curve or is it a straight line? What is it? Good. Yes. It is a straight line because it's y equals mx. You can see right here. How do we know this is y equals mx? Simply when you have an equation, if you want to determine whether it's y equals mx or y equals mx squared, I taught this in the 4th unit for gas laws for the 26 batch. If you joined, you know. Here, this is the y-axis. What do we have in the y-axis? The pressure. Now since we are drawing the graph for A gas, this is the pressure of A gas. So we have pressure of A gas, write y here because in the y-axis we have that. In the x-axis we have the molar fraction of A, therefore here write x. We know that this is a constant, then it's m. Then it's y equals mx simply. You need not to think what's happening here, you just use a mechanical way, then it's easier. You no need to think. For this you can think, it's easy, but for some complicated equations it's difficult to think. Simply write y in front of the term which is in the y-axis. Simply write x in front of the term which is in the x-axis. Then if there's a constant, put a m. Then you will get y equals mx. Therefore this should be a straight line. This is a straight line. This is a straight line. That's the graph for A. In yellow color, this is the graph for A. We'll use 3 separate colors for the 3 graphs. Now we need to draw the graph for B. The graph for B. Okay. Now tell me, when XA is now what? Now we can't use this equation for B. We need to use the another equation. What's that equation? For B we can use okay. For B I am going to use PB is equal to P naught B XB. I am going to use this. PB is equal to P naught B XB. Right now tell me, when XA is equal to 0, what is PB? Then this graph is done. Now we are going to draw another graph. When XA is equal to 0, what is PB? XA is equal to 0. What is PB? What is PB, not XB? I am asking the pressure. Yes. Good. When XA is equal to 0, hari මේවා හිතලා අඳින්න පුළුවන්. Like පොඩි දේවල්. When XA is equal to 0, XB is equal to 1. When XB is equal to 1, PB is equal to P naught B. Therefore, you need to mark some value P naught B. Now, we don't know whether P naught A is the higher value or whether P naught B is the higher value. We simply don't know the relationship. Therefore, for the moment, I'll assume that P naught B is higher. Then we'll discuss the conditions to that to be correct, right? I don't know. For the moment, I am assuming that P naught B is higher. Therefore, we'll get a P naught B here. XA is 0, XB is 1, therefore P naught B is here. In this end, XA is 1, therefore XB is 0, right? XB is 0. Since XB is 0, PB is 0. Again, the relationship is linear. Something like this. So, in yellow color, pressure variation of A. In light blue color, pressure variation of B. Is it clear? Very general concept. Sorry, we have to use this is one of the most common concepts which is asked in questions. They will ask few things. You need to be able to read this graph, do calculations. First, you need to understand what's happening. Then, in green color, I'll write the total pressure. The total pressure. How to get the total pressure? Now, this is the pressure variation of A. This is the pressure variation of B. According to Dalton's partial pressure law, we know that the total pressure is given by the sum of these two pressures. Sum of PA and PB, right? That's the total pressure. Then you need to add this graph to this graph. You need to add this graph to this graph. It's not that easy, right? You need to add all the points. So what we are going to do is again consider the ends. We are going to again consider the ends. If I add this value to 0, it's again this value. Is it clear? This end, I am going to add this PB value to this 0, then the total pressure is again that value. If I add this end to this value, again it's this value. Why? Because it's adding this to 0. I know the end points. Is the relationship linear or curved? How do we know whether the relationship is linear or curved? Make a kelling irak denne curved. Can you directly say it, whether it's linear or curved? Think. It can be curved, we don't know. Is it curved or is it linear? Someone try to confirm. I'll give you a hint. Now I could have just said whether it's linear or curved, but I want you to think. Now, someone try to write an equation. We know that PT is equal to PA plus PB. Right? PA is equal to P naught A XA. PB is equal to P naught B XB. Try to further simplify this and tell me, try to confirm whether this is y equals mx or something else. Make a simplify karanna, you can simplify this because instead of xb you can write y in 1 minus xa. Then we have only one variable which is xa because these two are constants. Then whether it's y equals mx or not. If it is y equals mx, it's a straight line. If it is not, we need to see. Bala. Check whether you get it. Whether it's y equals mx or not. Confirm. Someone. Kohari pattaka liyala confirm. Is it linear or not? Can you rearrange this? Okay, it says yes. I've got a few answers saying yes. Balan, it's P naught A. I'll keep XA. Now I have two variables. I want to reduce it to 1. I'll write 1 minus XA. Then I'll rearrange the terms. It's P naught A XA plus P naught B minus P naught B XA, right? Then I'll factorize the XA part. Then I'll have P naught A minus P naught B times XA plus P naught B. This is just a constant, right? Yes. Then this is PT. Now we are drawing the graph for PT, therefore this is Y. This is a constant which is M. This is in the x-axis, therefore this is x. This is again a constant, therefore it's plus C. This equation is Y equals mx plus C, which should have an intercept. Hari intercept act, this is not Y equals mx, which is clear, ne? Look, it's not Y equals mx, it's not crossing any of the origins. Both of these are origins, both of them. Different type of graph, origin, right? So it's not crossing either of these, so therefore it makes sense. It's not Y equals mx, but it's Y equals mx plus C. We are only bothered about the mx part, therefore this is a straight line, right? Y equals mx plus C is a straight line with the intercept, which makes sense. Therefore, it's this, a straight line, right? So you get the idea. Instead of just drawing the equations, I proved you that this is a straight line. Hari? No need to prove, but I proved you. Right, now under the topic, the what did we write? Liquid pressure composition, vapor pressure composition diagram. You can write down this table and then on top write that assume P naught B higher than P naught A. Assume this and then draw this table. Just don't copy the board. Understand the concept and draw the table, right? First draw the yellow line, understand how you got it. For that we use this equation for the yellow one. And then for the blue line, we use this equation. Then for the green line, we use this equation and added the graphs, and we understood that by adding the graphs again you will get a linear relationship between the total pressure and the molar fraction. Hari, godak kada karla me graph එක ඇන්ද. Therefore just don't copy, then you won't understand anything. You need to understand everything. Hari, graph එක දාගත්තා, මේ ටික දාගත්තා. Hari, write anything you want. Make sure that you understand it properly. Hari, දාගමු ටක් ගාලා. I'll give you few minutes. Right. Hari, if you want me to switch to the next slide, you can ask. Hari, but you need to be able to do the proof by your own. You need to show that XA has a relationship, a linear relationship between the total pressure. Yellow graph using this Raoult's law, blue graph for B using that Raoult's law, this using Dalton's partial pressure. So this is the key for the graph, right? A, B, C. Pressure of A, pressure of B, total pressure. I will give you 2 more minutes. අඩුපාඩු තියෙනවා නම් හදාගන්න. If you have questions, if you have doubts, ask me. හරි? Right, එදින වෙලාවනේ. Right, then let's continue. Is this clear? You have any questions? Can you share the previous, not the previous කියන්නේ පස්සේ එකනේ. This one. You want me to share this? Or is it the previous one? Is it this? This මේක නෙමෙයිනේ නේ මේක කරානේ. This is the 6th one and this is the 7th one. Could you please show the upper part in the 6th slide, please? What? This one? it's just that name. මේ මොනවද ලියන්න ඕනේ නැහැ. No need to write anything. It's just I showed that when you change the molar fractions that the pressures and everything will change, therefore you can get a graph. Hari. The only thing is you need to copy is this part. Right. Hari. Enough time, right? I'll give you one more minute. Mona hari doubts තියෙනවා නම් clear it quickly. We have only one more theory. Then 90% of theory for questions is done. Hari. Then මේකත් ඇතිනේ. For the next topic can write. Before that, before writing the next topic, here now we made an assumption. මෙතන පොඩි assumption එකක් කරානේ. What was the assumption? That P naught B is higher than P naught A. Normally in questions they won't give this directly. Then it's easy, right? Now here what is high? Whether it's P naught A or P naught B is determined by this assumption. They won't directly give it. They can give it. This is one way. Determine in the upper point, they can either give that P naught B is higher than P naught A or vice versa. Doesn't matter. Or else, they can say, now tell me, looking at this, is A more volatile or B more volatile? What is more volatile? Think if P naught B is higher than P naught A, which is the maximum pressure which can be contained or which can be stored. If it is higher for B, what is more volatile? Is it B or A? Yeah, it's B, right? So if the maximum pressure or the saturated vapor pressure is high, then you can, the meaning of having a higher saturated vapor pressure is that it is more volatile. It produces more vapor. තව vapor හදන්න පුළුවන්. It easily vaporizes, right? That's the idea. Therefore, instead of giving it like this, they can say B is more volatile. That's one way which they can give the same thing for this same example, right? B is more volatile. Or else another way, if B is more volatile, which boiling point is higher? Boiling point of A or boiling point of B? If B is more volatile, what has a higher boiling point? Is it B or A? What has a higher boiling? Yes, it's A, right? If a compound is more volatile, then it will easily boil. Then the boiling point is low, right? Therefore, they can say the boiling point, we write the boiling point like this. Boiling point of B is less than boiling point of A. So there are three ways which they can give the exact same idea. Write it as a side note because this is given in every question. Then you can decide what has the higher value. Either they can directly say this, or else they can say B is more volatile, or else they can say the boiling point of A is higher than the boiling point of B. If it is the other way, if this is higher, then all of these will switch. තේරෙනවනේ? Right. මේකත් පැත්තක දාගන්න. How many days do we have for A levels? I ask this every week. $230. Okay. Mahansenna, it's 2:30, right? Now try to put in 10-hour, at least a 10-hour day, right, of work. Put in 10 hours of work at least දවසකට. Try to find free time as much as possible. Try to arrange your classes in a way that you have free time. Hari. So the ways you can do it is try to always join classes live. Try to understand everything in the live session. Avoid recordings as much as possible. If you don't understand, you will have to go through the recording, but try to understand everything. තේරෙනවද? Then you can okay, I'll explain it again. Right? So you can avoid watching recordings. Try to always join live because watching recordings will be always inefficient for most students. If it is efficient, then fine. And also try to find time slots which you waste time, especially when you are joining a physical class or even for an online class. Before the class starts, you waste a lot of time, and after the class also you waste a lot of time. Now for an example, for this class is finishing at 11:40, then no need, you can just sleep if you want. If you are sleeping at 12, then you can sleep. But if you are sleeping at 2, then you won't do anything until 2, then you will sleep, you will waste a lot of time. But if a class finishes at, let's say, 8 p.m, a physical class, if you are joining for a physical class which finishes at 8 p.m, you won't do anything for the rest of the day, right? You will go home at 9, just scroll through your phone, and then you will somehow wait until 12 p.m or let's 12 a.m or 1 a.m, then you will sleep, you won't do nothing, you won't do anything, right? So identify the places which you actually waste time, then you will all of a sudden realize that you have a lot of time. Even though you think your schedule is busy, you have a lot of classes, you can't avoid having a lot of classes now, because you have the theory classes, you might have revision classes, you might have paper classes, and you might have even individual classes as well. So you have arranged those classes because you think those are necessary. If you feel that one class is unnecessary, if you are brave enough to stop that class, then that's up to you. That's a case by case scenario. But apart from that, you are wasting a lot of time. I know that by experience, right? So try to figure out those places where you waste a lot of time, try to minimize those, and create a schedule which should be practical. Then slowly, step by step, try to increase the hours you put into work. Hari, නැත්තම් මේක අමාරුයි, right? Always you need to understand that a very small amount will get opportunities to join good degrees, reputed degrees in government campus, right? Government universities. Therefore, you need to put in the effort. දැන් කරන්න ඕන. Otherwise, it's a waste of time. You are just wasting your time in classes. අපරාධ තේරුමක් නැහැ. If you just get, let's say you get 3 C's, then it's considered as a waste of time in my opinion. At least you need to get 3 B's. That's the minimum. In order to say that I got the maximum out of A level, you need to at least get 3 B's. You have degrees for 3 C's, even for S3 to 1 S2 C's, you will have a degree, right? You can join a private campus even. You have opportunities. It's not the end of your life after A levels. You have a lot of opportunities. But then this A level period is a waste of time. Aparad, you could have straight away done those without doing A levels, right? So the minimum is 3 B's. So you need to feel the pressure, you need to feel the heat. Hurry. If you know that you can achieve this, then try to achieve 3 A's. If you know that you can achieve 3 A's, try to go for the merit list. Try to get a good rank. Then it will help your friends as well. Then it will help your self-esteem as well. I think what you know. Hurry, getting a good rank won't change anything. So the value for 3 A's and value for a good rank is the same. Ne? Government rank. If you have the cutoff, then you will get in. But always try to get a higher rank. Hurry, you don't know. Even 3 A's might not be enough for some government universities, right? We don't know. It depends. Maximum. For that, always try to manage your time. පුළුවන් තරම් effort එක දෙන්න classes වල කියනවා දේවල් තේරුම් ගන්න try කරන්න. If you have doubts, you need to ask me always for the subjects. Try to balance the subjects. Do questions as much as possible. Do papers as much as possible. Join the paper discussions. Anam karla. Do everything, right? Do everything possible. Then only you will get a good result, right? That's why I ask you to, if possible, join the paper class as well, right? It's not compulsory, but if possible, it's good. It's better. If you are not joining, always then make sure that you do a lot of questions. If that's not happening, then better join the class. You can taniyen papers karana තේරෙන්නේ නැත්තම්. If your ethic is not that good, hari තේරෙනවනේ. Therefore, make sure that you have no regrets after your A levels, right? I have met a lot of students, even my friends, who have regrets regarding their A levels. They actually have realized that they lost a huge opportunity. Hari, even also doing a second try and a third try is considered as losing some sort of opportunities, right? Because then then you will be losing time. You might get a good result in your second try. First try you just do it, and then thinking that I'll do better in the second try, and you might actually do it. But again, then you have lost 1 year. Hari, තේරෙනවනේ? I said this for the 2025 batch, not the 2024, the 2024 batch. After their A levels, even after your A levels, there is a 1.5 year or 1 year a period which you do nothing until you get your results and you get selected for your universities. In that period also you have a significant amount of things to do. Otherwise you will feel when you get graduated or when you are in the third year or second year that you are way behind comparing with the world. අපි මේ ලෝකෙ එක්ක බලද්දි මාර පිටිපස්සෙන් ඉන්නේ. හරි, we are at least 2 to 3 years behind comparing with the world. හරි. නිකන් normally if we take Singapore, Malaysia වගේ ගත්තොත් even in US 22 years වගේ වෙද්දි they get graduated. There's a significant advantage I think. Because we are competing with the world නේ. jobs වලට compete කරන්න world එකත් එක්කනේ, ලෝකෙත් එක්කනේ, global market එකක් නේ තියෙන්නේ. It doesn't matter what job you do. For all the scenarios this gets applied. හරිද? ඉතින් ඒකින්ද තව shy එකක් කරන එක කොහොමත් not if you have to do it, it's another story, but now it's not an option. තේරෙනවද? Therefore always understand the situation. මම මේ හැම සතියෙම කියනවා I remind this each and every week, but you need to have the discipline, you need to understand this is your exam, so make sure that it happens, right? At least if you are a very weak student by now, weak කියන්නේ the situation which you are facing now, right? ඒක absolute දෙයක් නෙමෙයි, weak students කියලා જાතියක් නැහැ. If you haven't done enough work, then you are weak. If you have done enough work, then you are not weak. That's it, right? At least try to get this. නැත්තම් අපරාධ. This is possible, right? This is possible. You have 230 days, which is roughly 8 months. Stop wasting time. If you want to put your phone aside, make sure that happens. There are some students who even deleted all the social media and gave the phone එක කොහරි ගෙදරට දීලා, then for classes they join using their parents phone. If that's required, you can do it. I myself did it. මට ඒක ඕනේ කියලා හිතුණා because I hadn't done enough work. I wasn't satisfied with my commitment. ඉතින් මම ඒකත් කරා. හරි. එහෙම try to do everything possible. Hari, then you know, even though getting actually the result doesn't matter, you need to make sure that you don't have any regrets. ඔයා කරන්න පුළුවන් maximum එක කරා කියලා you need to make sure, right? Otherwise that regret will hurt you a lot. ගොඩක් කල් යනකම් it will hurt you. There are students in our university as well who regret not being able to achieve their dream, which means some students wanted to actually get into the engineering faculty. They couldn't, simply because of their mistakes. Hari, engineering faculty me annone කියලා එකක් නෑ, but they wanted, right? It's not compulsory, but they wanted. Therefore they knew that they missed that opportunity simply because they didn't work properly. අපරාධ කියලා ඒගොල්ලෝ දන්නවා. හරි, ඉතින් ඒකින්ද මේක පොඩ්ඩක් බලන්න. And also the other way, there are students who did the third shy or the skipped 1 year and then did the fourth shy and then joined the EFAC. හෙන වයසයි ඒගොල්ලෝ. හරි. They know that they have a significant disadvantage considering the age gap, right? There are students in my same batch who are 3 years 2 years elder than me, then they have a significant disadvantage. They are not, ඒකට regret කරන්න නැත්නම් because simply they knew. Now in the third side that person wasn't a different person, the same person, the only difference that he understood all the issues or the things which he didn't complete in the previous shies. කලින් ඒවා කරපු වැරදි අඩුපාඩු ටික තේරුම් ගත්තා. That's the only difference, right? Then that person has the regret, මම first shy second shy හරියට කරේ නැත්නම් අපරාධේ. Waste of time. 2 years. I wasted 2 years of my life just to do A levels 2 more times. අපරාධනේ. එහෙම වෙන්නත් බෑ. තේරෙනවනේ. Therefore this is the only option. This the first shy is the only option. This shy is the only option. Make sure that this happens, right? මේක අනිවාර්යෙන් කරනවා කියන එකයි, right? So put in the effort. I always remind you this. I don't know whether in other classes they remind you, but make sure that you are well aware of the situation. Hari, හැමතිස්සෙම කම්මැලි හිතෙද්දි නිදිමත හිතෙද්දි keep in mind that you only have 230 days, right? That's a very small amount. That's roughly 8 months. අටකුත් නෑ, it's like 7 months. පොඩි වෙලාවක් තියෙන්නේ. Hari? Right. And there's a question when XA okay, I need to explain this, ne? Okay, what I said here is that now we got this value higher than this because of this assumption, right? In this question, for this question, we assume this. In your paper question, they will give either this is higher or this is higher. But there are 2 more ways which they can give this. One way is that instead of giving this, they can say B is more volatile, right? When the volatility is higher, the saturated vapor pressure is higher. So if instead of this, they can say B is more volatile. If a compound is more volatile, then the boiling point is low. then the boiling point is low. Therefore, if this is the situation, then they can say the boiling point of B is less than the boiling point of A. Therefore, T naught B is less than T naught A. බලන්න මේක තේරුම් නැත්නම් right? And there's another question. When XA is equal to 0, can't it also mean that all of liquid A has... no, that can't happen. Why can't that happen? Now there's a question asking that if XA is equal to 0, then can't we think that all of the gases, all of A liquid is vaporized? හොඳ ප්‍රශ්නයක් ඒක. Now there's a question saying, now we assume when XA is equal to 0, PA is 0. The yellow line is for A. Therefore, when XA is equal to 0, when XA is equal to 0, we wrote that in this graph, PA is equal to 0. Instead of that, there's a question saying, can't we assume that XA became 0 because all of A liquid got vaporized? Therefore, can't we say that PA is not 0? Do you understand the question? There's a question saying A liquid is the XA or the molar fraction of A is 0 because all of A got vaporized. Therefore, we can't say that A gas is the partial pressure of A is 0. Why isn't that true? Why can't all of the A liquid go and vaporize? Why can't that happen? Why can't that happen? Why can't all of A liquid go and vaporize in this scenario? Can the entire A liquid vaporize? Can it entirely vaporize? Yeah, exactly. This Raoult law entire concept is discussed for the equilibrium between the liquid and the gas. If you maintain the equilibrium, then either of these, both of these actually should be present. එකක් ඉවර වෙන්න බෑ. Then the equilibrium has been disrupted. Then we can't consider the Raoult's law. For this scenario which we are considering the Raoult's law, which we proved all the equations, these two should be in equilibrium. Therefore, this can't entirely finish. That's the answer. Hari? I hope that answered the question. Hari. හරි නේද ඒක උත්තරය ආවනේ right then shall we move on hari we have one more topic with that we can finish the session for today hari ඒකෙන් theory to almost ඉවර වෙනවා and I'll ask you to do a question before joining next week on as a past paper question and not on next week after that you will get your tunes. For next week also you will require the tunes, then I'll share that part in the Zoom chat or as I'll screen share the maker. On the third week you will get the tune. Hari? Next week also product tune එක ඕනේ වෙයි. කවන්නේ. Hari, this is okay. Right, write the next topic. තා පොඩි වෙලා අයියා. පොඩි වෙලාවේ focus කරන්න. Next topic. Temperature, boiling point, in brackets boiling point, you will understand why. Boiling point, composition diagram. Temperature, in brackets, temperature, in brackets boiling point, composition diagram. right? Temperature in brackets boiling point composition diagram. Here what we are going to do is, now in the previous diagram we demonstrated the relationship between the molar fractions and the pressure. Here we are going to demonstrate the relationship between molar fractions and a boiling point. We will see what boiling point. So here it's temperature, and here it's the molar fraction, right? Right? Then it's the molar fraction. Let's write XA. It's 0 and 1. For XB it's 1 and 0. Now this concept is little bit confusing because we are not learning the entire concept. It's little bit complicated. Now we don't know an equation for this even. Now for the pressure and the molar fractions we had an equation, the Raoult's law. For this one we don't have an equation. But this is also very important. This is also asking question. Okay, first we'll try to okay, good. Right, now maybe done go. Maybe that. Assume that XA is 1, right? XA is 1. Then what is the temperature which we should give, right? What is the temperature which we should give to boil the entire to boil the solution, which means all of the XA, which means all of the liquid of A should convert into gaseous A. Is it clear? That's the boiling point, right? Now this graph is about boiling points. Now we are going to draw a curve, plot a curve. The relationship should be the boiling points of the solution with respect to the molar fractions. Now what I am asking is, when XA is equal to 1, when XA is equal to 1, what is the boiling point? What temperature should we give to boil the solution? What is the temperature which we should give? Now again we'll assume the previous conditions, right? We'll assume the previous conditions. What's the previous condition? It was, what was the previous condition? This one. B naught B is higher than P naught A, right? I am assuming this condition. P naught B is higher than P naught A. Right. Tell me. To boil a solution with XA is equal to 1, which means we we only have A. To boil this, what temperature should we give? What is that temperature known as? A vitarak in ekak boil karanna, the temperature which we should give is known as what? Tackle again. What is it known as? Now if you have water, let's say liquid is water, then if you want to boil it, if you want to boil water, then the temperature which we should give is known as what? What of water? Yeah, the boiling point, the boiling temperature, right? That's what we should give, right? Now for XA is equal 1, we only have A, therefore boil the entire solution, we should give the temperature which is equal to the boiling point of A. Is that clear? It should be equal to the boiling point of A. To boil a solution with XA equals to 1, which means we only have A, then we should give the boiling point of A. Let's write the boiling point here. T naught A, which is the boiling point of A. Right. The same question for this side. When XA is equal to 0, XB is equal to 1, then to boil a solution with xb equals to 1, which means the boiling point of b, then we need to give the boiling point of b, right? To boil a solution which only contains b, which means xb is equal to 0 and xb equal to 1 and x is equal to 0, we need to give the boiling point of b. What is higher? Is it the boiling point of a or the boiling point of b? What is higher? Looking at this relationship. Exactly. Since P naught B is higher, T naught B is less than T naught A, which we understood. Here, we wrote it down. Right? Okay, everything should make sense. So this is the relationship. Therefore, T naught A should be higher and T naught B should be less. Right. And the actual relationship is complicated since we don't have a equation. You just need to know that the relationship is curved. It's not a y equals mx. The curve should go like this, and you need to make sure that this is the minimum and this is the maximum. So no point should go above this and no point should go below this. This is not the minimum. This should be the minimum. When you are drawing, make sure that you maintain that. So this should be the minimum. Right? So this is the relationship. Is it clear? Now we will try to read the for the moment, just draw this. Now you have no idea on what's happening here, but we know about the ends. We are okay with the ends. We understand the end points, and then I just said that this is a curve. Therefore, you just believe what I say, and then you draw the graph. Temperature, boiling point, name the axis, and then write this relationship. Therefore, it's this. Then what is more volatile? B is more volatile. B is more volatile here. The same conditions as in the previous one. B is more volatile. Then using it, you can write down this. If you want to explain one end, you can explain here when XA is equal to 1. It's simply a single liquid in a container. To boil it, you need to give the boiling point of that substance. For this side also, you need to give the boiling point of this. Then we'll try to explain the middle part. It's difficult, middle part. Right. If this is clear, right. Now tell me this number make again. Now if you have let's say 5 moles of water in a container, may concept this is not the right time to teach this, but can't help. And then now if you have 5 moles of water in a container and if you provide the boiling point, how many moles will vaporize? If you have 5 moles of water in a container and if you provide the boiling point, now we are trying to understand this middle part. How many moles will vaporize? Pahak tiyena water, you give 100 Celsius, then how many moles will vaporize? If you give the sufficient amount of time to vaporize. Pahen kiyak vaporize venawa? Yeah, all of them will vaporize, right? Simply the 5 will vaporize, right? It won't stop. Will it stop? No, it won't stop. Okay. Then try to answer this. Here, now let's take one point. I'll take this as point, 0.5 again. This is 0.3 and this is 0.7. The molar fraction of A is 0.3, molar fraction of B is 0.7. Then there's a boiling point which is relevant to this solution. Is that clear? For each composition, there can be so many combinations. There are infinite combinations considering the composition. For this specific composition, there is a boiling point which I'll write as, let's say, T1. That's the boiling point. That's the boiling point. T1. So if you give T1, then that's the boiling point for this specific composition. Is that clear? There now. Let's say now in this container you had the molar fraction XA is equal to 0.3 and then XB is equal to 0.7. This one. Then you gave the T1 temperature. So I am giving the exact condition which is required. Then I am giving T1 temperature. Then I am saying, I am just giving you help, I am just helping you, I am telling the entire solution won't evaporate. Now if you only had one liquid, if you give the sufficient amount of time, the entire solution will evaporate. But here it won't evaporate. Why? Can someone explain? It won't evaporate. You can use this also, which means the volatility is different. B is more volatile. In this condition, B is more volatile. Or else the volatilities are different. Try to explain that I am saying, if you give this, now this is the boiling point. Nothing wrong with the temperature. This is the boiling point of this solution. So if you give the boiling point, you expect the entire solution to evaporate. Vaporize, not evaporate. In the boiling point, it will vaporize. You expect the entire solution to vaporize. For one liquid, that's true, but for a binary solution, that's not. Can someone explain why? You need to start from the concept that the volatilities are different. Then what will happen? Try to think. If you can figure this out, then it's really good. It's difficult to think. I'll give you 2 minutes. right? Okay, we have few answers. බලමු මොනවද තියෙන්නේ කියලා. Okay, that's partially correct. So the idea is, since B is more volatile, even though you give the same temperature, according to logic, B should vaporize a little bit more than the amount A should vaporize. Makes sense, right? Because B is more volatile. That's the idea of volatility. B පොඩ්ඩක් වැඩිපුර vaporize වෙන්න ඕනේ. Because it's simply more volatile. Nothing to do with the molar fractions, right? Because of the molar fraction is high, no, that nothing to do with that. Because B is more volatile, it should vaporize more. Now, if B vaporizes more, what will change? Tell me. Now, there's a certain ratio which they are maintaining, 0.3 to 0.7. If B is more volatile and if it starts to vaporize more, then something will change. What will change? Yeah. If B starts to vaporize more, then the molar fractions will change. Is it clear? Why? A certain amount of B will vaporize. Now, here, the molar fraction of A is 0.3, the molar fraction of B is 0.7. If B starts to vaporize faster, then won't the molar fraction start to reduce, and then won't the molar fraction starts to increase? It will happen, right? Then what will happen? Then what will change? If the molar fraction start to change, then what will change? Okay, correct. If this starts to change, then what will change? If the molar fractions change, now you are looking at what's changing. Look, me board de lokuwatama thiyenne change වෙන එක. If the molar fractions change, then what will change? ලොකුවට ලියලා තියෙනවා මේ board එකේ. What will change? Yeah, the boiling point will change. You can see, right? For this smaller fraction, there's a boiling point. Now, if the molar fraction change, then the boiling point will change. This is not just the temperature, right? These are the boiling points. The boiling point of that liquid will change. Then what will happen? Then it's a continuous process. Now, since the molar fraction changes, right? The molar fraction changes. Now, look at this. Now, here, since B is more volatile, this will start dropping and this will start increasing. Then it's like, let's say XA will be 0.4 after 5 minutes and XB will be 0.6 after 5 minutes, which is somewhere around here. Let's say this is the point. Then the new boiling point is higher than the previous one. Is it clear? Why does it become higher? It should be understandable, because the more volatile one is vaporizing. Then the average boiling point should be higher. දැන් මේ භාජනයේ ඉන්නේ, the composition of this container is biasing towards the non-volatile part, ne? Because the more volatile one is vanishing. Now we have more non-volatile substances. Is it clear? The boiling point will start increasing with time. Then is this temperature sufficient to boil this down? No. So it will be a continuous process. It's not simple as having one liquid. If you have only one liquid, the boiling point will be constant. Therefore, the entire thing will vaporize. But if you have two liquids, once you give the boiling point for that certain composition, as soon as you give that temperature, the more volatile one will start to vaporize, which will result a change in the molar fractions. Then the boiling point will increase. Then this boiling point won't be sufficient to boil the entire solution. Then if you give this temperature, if you give the higher temperature, again the molar fractions will change. Therefore, the next boiling point will be more higher. Then again it won't be enough to boil the entire solution. That's the idea of having two liquids. So it's difficult, right? Poddak complicated. Logically you need to understand what's happening here. So altogether you just need to understand, when you have a binary liquid solution, giving one temperature won't boil the entire solution. Mulu solution you can't boil, it's difficult. Right? You can, I'll teach you that later. But the main theory is that when you boil the solution by giving the temperature which is relevant to that, by giving the boiling point which is relevant, the entire solution won't boil. Again, fraction එකක් තමයි boil වෙන්නේ. So don't expect the entire solution to vaporize. That's the idea which I wanted to give you. I took a lot of time to explain that. Is it clear? I won't write it down, that's not necessary to write, but if you are interested, you can write it down. What's the idea? When you give a temperature, because that's not necessary, those things won't be asked for your A-levels, but I don't know, the logic, having the logic understood is better, right? Once you give a temperature, the more volatile substance will start to vaporize. Then the molar fractions will change. Since the molar fractions change, the boiling point for this solution will increase. Then this won't be enough to boil the entire solution. Right? That's the idea. Is that clear? That's the idea. So this is considered as the minimum boiling point, because after you start boiling, the boiling points will increase, as you can see in the value of boiling points. Right? Okay. So if you want, you can write that down. It's up to you, no need, because normally in questions they won't ask about this graph, they will ask to do calculations, but if you are interested, you can write. Therefore, now you can understand, if you boil a solution with a certain molar composition, it will change in the vapor phase. You can't expect the entire solution to vaporize. To demonstrate the vapor phase, we draw another graph. This is the vapor phase graph. Now you might think the theory is complicated, but what I taught up to now is not being asking questions. You just need to be able to manipulate the graph. My graph එක කියවන්න තේරෙනවා නම් ඇති to read the graph and manipulate it. So this demonstrates the composition which is in the vapor phase. So this demonstrates the composition in the liquid phase. So I'll briefly explain how we can use this graph. Then you will understand it very easily. If you want, you can forget about that concept. Doesn't matter. හරිද? Now මේ බලන්න වෙන දේ බලන්න. Pay attention. තා පොඩි වෙලාවයි තියෙන්නේ, right? I'll go on for like 5 more minutes, then that's it. Let's assume we had this molar fraction in the liquid phase. Then draw a line like this. මේක හරියන්නේ නැහැ. මේක පොඩ්ඩක් කැත එන්නේ නැහැ ලස්සනට. Let's assume we had this fraction, then it's easy to show. Let's say xa is equal to 0.7 and xb is equal to 0.3. Not this, switched. Then I'll erase all these unnecessary parts. You just need to be able to read this. බලන්න whether you can read this. Hari? The boiling point or the minimum boiling point of this solution is this temperature. Let's name it as T dash. That's the minimum. So you need to be able to identify the minimum boiling temperature. If you give that temperature to the container, simply the entire container, now this is not the fraction, this is 0.7, this is 0.3. Simply the entire container, the entire solution won't boil, which means a fraction will boil. The fraction or the composition of the vapor phase can be given by drawing a horizontal line. So this will be the value. So you can check the value here. Let's say it was 0.2 and 0.8. We don't know the value, it's just depending on the graph. Let's say 0.2 and 0.8. Then you can conclude that the composition in the vapor phase is 0.2 and 0.8. That's only you need to read. එච්චරයි කරන්න පුළුවන් වෙන්න ඕනේ, right? You simply need to figure out the molar composition of the liquid phase, mark it on the liquid phase diagram, then identify the minimum boiling point. It's just a horizontal line, so no need to understand the entire concept. If you want, you can, but not necessarily. Then draw a horizontal line, then it will meet the vapor phase diagram. Then on the vapor phase, you can read the vapor phase composition. So the idea of this graph, if I show it practically, the idea of this graph is something like this. Let's say you had a solution which had xa 0.7 and xb 0.3, this one. Then the temperature which you are supposed to give is T dash. Once you give T dash, a certain amount will be vaporized. Then the composition in the vapor phase is Ya, the molar fraction of A is 0.2 and then molar fraction of B is 0.8. Again you can see that B has been vaporized a lot. Make a godak in B. Lot of gas is B. Why? Because B was more volatile. Previously we discussed. Since B is more volatile, the molar fraction of B is higher. Right? That can be also understood. We'll discuss these concepts furthermore later. But for the moment, you just need to have the basic idea to identify the liquid phase The minimum boiling point and the vapor phase composition. That's it. That's enough for the moment. Right? Right. Okay. Then after the topic, draw this graph. No need to explain how we obtain the graph. You just have a rough idea. No need to write it down. Not necessary thing. And this graph is for the liquid phase. This graph is for the liquid phase. This graph is for the gaseous phase. Right? Gaseous. In middle we normally name that as the gas liquid equilibrium. මේ මැද කැලලට අපි කියනවා gas liquid equilibrium කියලා. ඒක පිළිවෙලක් වෙන්න ලියාගන්න. Right? Now writing these will make this a mess. Therefore you can write these somewhere else. මෙතන ලියන්න ඕනේ නැහැ. හරි? I'll just erase it for the moment. Write it later. But I want you to write properly and clearly is this 3 points. This point, this point, this point and this point. Right? Okay. Properly demonstrate that. Write this graph. මේ මුලින්ම graph එක අරගෙන මේ ටික නම් කරගන්නකො පිළිවෙලට කොහෙ කොහෙ හරි. හරි. Then mark all these points and simply write a sentence which explain all of these. So the sentence should be consider a solution which has this fraction in the liquid phase. Then the minimum temperature, minimum boiling point will be this. And the vapor phase composition will be this, or else you can draw this diagram. Doesn't matter. I'll answer the questions until you draw this. Hurry. If both A and B is present and temperature is increased to boiling point of A. Okay, that's a different story. Now we are only considering the minimum temperature. Now there's a question regarding if you give a higher temperature than T dash, what will happen? That's a different story. We'll discuss that on next week. And T dash so now if you know that T dash won't be enough in the process and if you give a higher temperature, then what will happen? That's a different story. So for the moment what I want you to do is draw the graph. This is the gas phase, this is the liquid phase. In middle you can write just gas liquid equilibrium. Don't need to understand why. You'll understand later. Then properly mark this point, this point, this point. That's the most important part. We'll finish at 11:45. Sorry, I just wanted to finish the concept. And then the idea of this line, either you can draw a picture or you can write. This is the molar fraction of a given solution. For that solution you can find not the boiling point, the minimum boiling point. So you can give a higher one, then it's another story, we'll discuss it later. This is the minimum boiling point, a horizontal line. By giving the minimum boiling point you will achieve a vapor phase. The composition of that vapor phase is given by this value. Right? I'll give you 1 minute. Right, okay. Then that's it for today. What I want you to do is complete, just go through the entire theory before joining on next week, because we are, as you can see, we stopped in a sort of a complicated spot, and next day we will be discussing on non-ideal solutions which has deviation. Then all the graphs won't be linear, everything will be curved. Then the relationships can be a little bit difficult and everything can be kind of a mess. පොඩ්ඩක් මේ පැටලෙන්න ගන්න පුළුවන්. හරි, ඒකින්ද go through everything, then you will find everything very clear. හරි, මේ මාර clear වෙන්න උගන්නලා තියෙන්නේ, and once you do questions everything will be fine. And I just want to do a small question which has nothing to do with graphs. So even if you don't understand graphs, you will be able to do this question. Try the 2020 A level 6B essay. Roman number 1 is the proof, which we did. Try to do Roman number 2, which is very easy. I just wanted to give you an idea on how the questions are being asked using Raoult's law, not the graphs. The graphs will be asked for essays and structured essays, but for some essays and MCQs they will generally ask about the Raoult's law, the equation. 2020 A level 6B Roman number 2. Very small question, 5-minute question. Try that question. We'll discuss it later. Hari? Then you will have a small idea. Hari? And the most important part is just go through theory. Hari? Right, then that's it for today. Right? Try to give your maximum. And let's try to get a good result. Hari, එච්චරයි වෙන්න ඕනේ හැමදාම අන්තිමට ක්ලාස් එක ඉවර කරලා යද්දි tell that to yourself, right? That I'm going to get a good result. Hari. එහෙනම් අද රැදි. If you have questions you can ask. If you want recordings, put a message. And also I'll inform on how to join energetics tomorrow if you want. Yeah, that's it. Thank you for joining. Right.